So welcome in this next tutorial where we will make a design of a device by using all the operations which we have learned earlier and a few basic options which we have covered in the previous, or I should say the first tutorial. So you can see a device design here. So we'll try to make that device design and we'll populate this design in the full 4-inch area. Also we'll learn how to make alignment markers in this tutorial. Okay, so let's get started. So as you can see, this device is having two layers. The layer one is having some finger pads. It's having connections, and in the layer 2 we have a covering layer. It can be of some specific metal, or it is maybe of silicon or silicon oxide, whatever, it depends upon your process. Okay, so just suppose this is a device which we will be designing right now. Okay, so we'll start from the basic, or I should say the simple design, then we'll move forward towards the complex design, the upcoming tutorial. Okay, so first I will delete this. So we'll start with the uh, contact pads or finger connections. Okay. So first I will make the reference by clicking on this reference tab, 0, and here also I have to find 0. Yeah. So you can see this is our x-axis and this is our y-axis. Now we'll start with the first layer. So in first layer we had some finger pad connections. So just suppose I will make a rectangle and I will define its width and length. Just suppose I want the width of 1000 micrometer, that means 1 mm, and a height of 1 centimeter, that means 10,000 micrometers. So I'll click OK. So we have got this big rectangle now here. Now just suppose we want some finger connections. So what I will do is I will just copy it and paste it here. Now the another same rectangle is just above this rectangle, so, and I want that rectangle, the next one which we have copied just now, to be acting as a finger. So what I will do is I will rotate it by 90 degrees, then I will change its property. I will change the width or length, or what I can do is I will change the width and length first, then I can rotate. It's up to us. So first I will like to rotate it by 90 degrees, and again I have to fix some point. So just suppose I'm fixing this point, then I will click OK. So now you can see this point was fixed and it has got a rotation in anti-clockwise direction by 90 degrees. And now I will change its width and length. Okay, so just suppose I want a length of I should say 200 micrometers. Okay, and I want the width of just suppose 7000 micrometers. Then I will click OK. So now we have got a finger like this. You can move, drag and drop it here. Okay. Now what I will do is I will just move it a little bit downside. Just suppose I'm giving a grid size of um, 50 micrometers. Yes. Now I want to populate this along the full length of this big rectangle. So I will select this duplicate option. Again, I want to populate it in a single line, that too in -y direction. And I have to give the instances. Just suppose I want 12 instances. So I have to give 12 here. Then I should decide the vertical displacement also. So it includes its own width as well. So this is 200 micrometer. So we will give a 600 micrometer spacing. That means 200 plus 600 will be equal to 800, and that too in negative y direction. That means we have to put a minus sign here. So we'll give a minus 800 micrometer value. I will click OK. So I will get the population something like this. Just suppose I want to make it a little bit down, so I can move it manually. Yes. So now we have got the half of the design. Okay, now what I will do is I will select this full design. I will make it as a group because I want the same thing on the right side as well. So what I will do is I will copy this full group, I will paste it here, then I will do the mirror, then I will select the mirror option. Okay, so I will copy, I will paste it here. Now I will mirror it on its own position like this. So now after mirroring, it's coming like this. Just suppose if you want to see both of the things like separately, so you can change its layer just for some time, then you can change it back to the layer 1. Okay, so now you can see both of the groups. Okay, now just suppose you want the same gap between these two fingers. Okay, so now first we have to see how much gap we have actually. So if I measure this gap, we have 600 micrometers, because we have given total spacing of 800 micrometer. That means 200 micrometer of the width plus 600 the actual spacing. Okay, so just suppose I want 200 spacing on each side, because 200 will be width in between. Okay, so I will select the grid size to be 200 micrometer. So when I select the grid size to be 200 micrometer, if I move a little down, so this full thing will move by 200 micrometers. So it will come something like this. Just a minute. Yeah, so if I go down by one step, it will come something like this, because this full width is 200 micrometer and we have given the uh, grid size to be 200 micrometer, so it moved by 200 micrometer. Again, if we move further down, so it will come something like this. Okay, so now it's in the center exactly. Okay, but again, just suppose if I want this big rectangle to be at the same level, so what I will do is I have logged the layer 1. I will uncheck this, so it will be invisible. Now I will break it apart, because this is in a group, so I will break it apart. Okay, yeah, so now it's like it's having a lot of elements. Now I can edit the elements like separately. Okay, so now if I make the layer 1 visible and I want to move this rectangle, the big rectangle a little bit up, so we have gone down by 2 steps, so I will move 2 steps forward, like upwards, 1 and 2. So now these two are at same height. Okay, now if you select the layer 1, now you can move it a little left, so that you can get some specific gap. Okay, so whatever gap you want, you can change your grid size accordingly, and you can move accordingly. Okay, so just suppose I'm giving some random gap, so I've got some pattern like this. If I increase the gap, it will look something like this. Yeah, fine. So now our design is almost completed. So what we have done is we made half the design in the layer 1, then we copied the same thing and we mirrored it, then we converted it to layer 2, then we changed its property and we made it in layer 2, then we did some modification so that we can see both of the layers simultaneously, because earlier it was merging in itself, because it was in a single layer, it was in the same color. Now we can change the layer 2 part, and we can change it to layer 1. Okay, so I will unselect this design, I'll select this full thing, go in properties, I will make it to layer 1. Okay, so now it's not visible in layer 2, it's in layer 1 now. So now our device is ready. Okay, so again, now I want it to be in the center, so just suppose I will select this, we will go in layout, special, and center. So now it's in the center. Okay, just suppose I want to give a covering boundary, which you have seen in the main device design. I'll select the layer 2, I will lock the layer 1. Now I can select this rectangle option, I can make a covering rectangle like this. Yeah, so I've got a covering of blue color layer, or some other metal, or maybe some other layer of the device. So now our device is ready. So now it's time to populate this device design in the full 4-inch area. Okay, for that we need to change the background setting. So if we check, it's a 5-inch mask background, and in a 5-inch mask we'll be having a wafer of 4-inch. So it's correct, the area is already selected for 4-inch. If you want to change it, you can right click, go in background settings, you can change the wafer background settings from 4 to 5, 3, or whatever you want. Just suppose I want this device design in the full 4-inch area, so I will move it a little here, then I will populate in the full 4-inch area. Okay, so I have a lot of ways actually. So what I can do is, first I will populate this in a this full quarter, then I can copy this quarter and then mirror it in the nearmost in the right side quadrant. Then I can copy the full first half of the top thing of the top design, then I can copy and mirror that to the bottom side, or I can just move it a little bit here. Then I can do a duplication or in a array mode, so it will come along the full 4-inch area. Then you can delete the undesired devices which is coming outside your wafer. So I will select this, I will duplicate it in array. So just suppose I want the rows to be 2 3 4 5 6 7, just suppose 7 rows I want, and I want uh, the same 7 columns. Okay, now what I will do is I will give the spacing value. So just suppose this is a like single device which is covering this much of uh, height and this much of width. Okay, so I have to add the spacing, then I have to give the value. So device area or dimension plus spacing I have to give. So just suppose I want the gap between two devices to be 500 micrometers, or just let's say 1 mm, so I have to give 1000 micrometer extra in this row spacing and column spacing. So it should be 11,400 and it should be 11,000. Then I will click OK. So now I have got this array like this. Now I will select the full array and I will make it to center. So now this is centered properly. Okay, so now if you can see this part is coming close to the wafer boundary, so I will delete this part. Same here, I can do the same thing here as well. Okay, now if you can see we have a little space here, but it will come closer to the wafer. If you want, you can make one more device here, or it's just fine, it depends upon you. Okay, so now we have to give some alignment marker. Okay, if you see you have some little area here, you can put your alignment markers here, here and here, or here as well, or you can delete the central row of the device designs, or you can delete this column also, so that you can get alignment markers in the center. So we'll go with the first option, we'll put some alignment markers here, and same here and here. Okay, so first we will save this design. Yeah, so now we'll make alignment markers. Okay, so just suppose we'll not disturb the device layers, we'll lock all these layers, and we will make our own new layer. We'll make one separate layer for alignment marker, then later on we can move those alignment marker layer in the layer 1 or layer 2 accordingly. Okay, so I will give layer indices as 3. I will change its property alignment marker. Okay, so yes, marker. So now we will start with the basic alignment markers. We'll make a plus structure. We'll give its width to be 10 micrometer and height to be 100 micrometer. Yes. Okay. We'll reduce the grid size to 1 micrometer. Okay. We want it to be plus. So we'll copy this. We'll paste it here. We'll rotate it by 90 degrees. We got a plus. Now we will make it as a group. So now this is a single entity. Okay, now we want a bigger plus, so I will copy this, paste it here. I will move it a little down. Now just suppose I want the width to be 20 micrometer. Since it is 10 micrometer in width, I want it to be double in the dimensions. So I will select this. I will go in scale. I will make it 200%. So whatever dimensions we have given, it will get doubled. Okay, so now this is 20 micrometer width and 200 micrometer height. Again I want a bigger alignment marker, so I will select this, copy paste, move. Now I want a width of just suppose 40 micrometer. So again double 200%. Okay, so we have got the plus alignment marker, okay, of different sizes. Now just suppose if you want cross, just copy this, paste it here. Now I will rotate it by 45 degrees. Yeah, so now it's cross. Again I will increase the size 200%. Again copy paste 200%. Yeah, so now we have got plus and cross. Okay, just suppose if you want some more complex alignment marker, so I will just suppose copy this. And now just suppose if I want uh, to invert its design polarity, so I will select the inversion option. Just suppose I'm giving a boundary width to be 50 micrometers. Change its property to layer 3. Yeah. Now we have got a bright field plus. Okay, I will do the same with this cross. So now I've got this much of end markers. Okay, so this is a single set. You can make a lot of different kind of end markers also. Just suppose you want something like this. So just suppose this is your like end marker. In layer 2 it will be like ulta, in flip manner, or I should say mirrored manner. So whenever it's going a little up or down, you can see whether it's aligned or not properly. You will understand when I will make a copy in the other layer. Just wait. Now I will make a group of this full alignment marker. So this is our group 1. It's grouped. Okay, now just suppose I want to use this layer as well. I'll change its color to red, little red. Yeah, I'll copy this, I will paste it here. I'll move it to layer 255, which is in red color. If I uncheck this, it's in red color. Okay, but first I have to ungroup it. Yeah, I'll group this. I will flip this. If you can see, it can be moved. Yeah. So when your design will be fully aligned, it will look something like this. If there is some Y shift, it will come something like this in the layer 2. And if there is some angle misalignment, it will be at some angle. Or if there is some X direction misalignment, then it will overlap, or it will be having some gap. Okay, so you can reduce the width of this finger, or I should say align marker, to check the accuracy in a better manner. Okay, so we can do one thing, which is to invert the image. So the first layer, this first layer of the align marker, will fit in the bright field of the same thing in the other layer, or I should say in simple words. So how we will know whether this align marker is aligning with the second layer align marker? So we can reverse the polarity, or we can change the polarity of this align marker in the second layer. So this plus or cross will fit in the reversed polarity of the same alignment marker. So if I reverse the polarity of this plus or cross alignment marker, so there will be some hollow gap for plus or cross, so it will fit into this. uh, let's do this so you will understand in a better manner. I will select the layer 255, which is second layer of align marker. I will select this thing, or I should say, yeah. So I will select this thing. I will make it a group. Then I will do the inversion, and I will give a boundary of just suppose 50 micrometers. I will click OK. So now you can see the polarity has been changed for the layer 2 alignment marker. And if you see in the layer 1 of the alignment marker, it's fitting inside this layer 2 of the alignment marker. So what did I mean was, I will change the polarity of the alignment markers, the layer 2 alignment marker. So the layer 1 alignment marker will fit in the layer 2 alignment marker. So now you can see it is properly aligned. Okay, so when you will get this kind of structure in your device layer after aligning, so you will know whether it is aligned or there is some shift. Okay, so now this align marker group is ready, so now I can populate it around the wafer. So I will just make it as a group, and then I'll make one more copy, remove it. I will increase the grid size for fast movement. Yeah, so suppose I want a line marker in the x direction also, I will make it a copy. I will rotate it clockwise. Whatever angles you are giving, it will be giving you a anti-clockwise rotation. So for clockwise rotation, I have to give a minus sign. Okay, with respect to this point, because I want to fix this point. Yeah. So now you have got line markers here. If you want to move it, you can move it. Yeah. Now again, if you want this to be populated in the full 4-inch area, you will select this. You will select this option, duplicate. Again, you have to do radial array. Okay, or you can directly make it as a copy. You can paste it here. Now you can mirror it with respect to the uh, y-axis. Okay, so you can select this mirror. Horizontally you want to mirror, then that reference point should be 0 0, so you will click OK. So now you have got the same align marker here as well. Now if you want to copy this and want to mirror it with respect to the x-axis, so you can select this, then shift, select this and this. So now you have selected these align markers and these align markers. Now you can either copy paste then mirror, or you can directly mirror uh, by leaving the original file, design file, to be here. So you have two options. So if you click here, you don't require to copy and paste then mirror. You can directly mirror it by leaving the original design here. Okay, so that's another useful option. Now you have to select vertical. You can click OK. So it will make a mirror image of the same design in while by taking the x-axis as a mirror. Okay, so now you have got the device populated in the full 4-inch area, as well as your align markers in the full 4-inch area. So this is the easiest way to make a simple design like this. You can add more complexity to this designing procedure by adding a bit complex align marker. You can reduce the size. You can make the base thicker like this 10 micrometer, and you can add one more small rectangle of smaller width, so it will be like quite precise. Okay, and you can add a lot of other structures as well. Okay, so it's just a time taking process. The more complex line markers you make, the better accuracy you will get. In the upcoming tutorial, we'll try to make a device which is much complex than this device. So we'll revise a lot of operations which we have covered in the previous tutorials. So thank you for watching. Stay connected. We'll see you soon in the next tutorial.